So here's the plan. Steps for hypothesis testing. First step, state the null hypothesis and the equation for your null hypothesis. Step 2, state the alternative hypothesis and your equation for your hypothesis. Step 3, calculate your test statistic. Step 4, make your decision. And then step 5, state your conclusions. And so note that I have a different number of steps than what the book has. The book, I believe, has 8 steps. I have 5 steps. And these 5 steps are the same for all of the hypothesis tests that we're going to learn after quiz 2. And really, steps 1 and 2 we've done already. We know how to write out our null and alternative hypotheses, and we know how to write the corresponding equations for those types of hypotheses. And so let's talk about step number 3, which is calculating our test statistic. So calculating our test statistic. Well, the statistical test that you use to test your hypothesis is going to depend upon the level of measurement that you're using. So once we've established our null and alternative hypotheses, we have to think about, okay, which one is our IV, which one's our DV, and what are the level of measurements for those? And that's going to then dictate which test you're going to use. And each test has its own test statistic. So we're going to learn 5 different types of tests. The first 2 is the independent and the dependent samples t-test. And the dependent samples t-test is also known as the paired samples t-test. And these 2 t-tests utilize the t-test statistic. We're also going to learn about ANOVA, which is an acronym for One-Way Analysis of Variance. And the ANOVA statistical test utilizes and has the F-test statistic. Pearson's chi-square uses the chi-square test statistic. And Pearson's correlation coefficient uses little r test statistic. And this last one, we've learned that before when we learned about correlation coefficient and the relationship between 2 different variables. And so as we can see, we have 4 different test statistics that we're going to learn, but we have 5 tests because the t-test has 2 different types, independent and dependent samples. And so very generally speaking, without going into too much detail, because we're going to learn about each one of these in more detail in the weeks to come, each test statistic tells you how much different your data is from the null hypothesis. And so therefore a larger test statistic, whether it's a bigger or a smaller number, or a positive or a negative number, means that your data is very different than the null hypothesis. Again, we think about if there are no differences, if there is no relationship, what do we expect to see in the population? And so if that test statistic is large enough, if that difference is large enough, we can then reject the null hypothesis. And so of these 5 tests that we're going to learn, some you will calculate by hand, and others will be given to you in the form of SPSS or just given to you in your data. So let's take a look at this table here, and make sure you know this table in preparation for quiz 2, and obviously for the weeks to come and your final exam. So in this table we have the 5 different tests that we're going to learn. And this is kind of set up based on the table that we've seen before. When we look at the 2 columns, we're looking at our independent variable, and we're looking at our rows, we're looking at our dependent variable. And so let's take a look at the first column when we look at difference tests. This is when we have nominal variables, and when we have ordinal variables, when we're looking at the responses as groups and categories. So let's say we want to look at differences between men and women. We're looking at agreeableness levels, those who strongly agree versus those who strongly disagree. Right? We're looking at different groups. And if our independent variable is nominal or ordinal, and our dependent variable is also nominal or ordinal, then this is when we're going to conduct a chi-square test analysis. But if our dependent variable, if our outcome is ordinal, in the sense that we're going to, and we can, calculate a mean and standard deviation and make sense of that mean and standard deviation for this ordinal variable, Or if it's continuous or discrete, that's interval and ratio, then we're going to run either a dependent or paired samples t-test if we have one group, or we're going to do independent or samples t-test if we have two groups, or if we have more than two groups, if we have three or more groups, then we're going to do the ANOVA, the F-test. But if our independent variable is quantitative, and we're looking to see the differences or the relationship between quantitative independent variable and a dependent categorical variable, we're not going to learn the specific test. So what we are going to learn about, and what we have already, is looking at the relationship between two continuous variables, two quantitative variables. And I threw in here ordinal variables that we can calculate means and standard deviations for, thinking about quality of life, ranging from 0 to 100, and pain levels, 0 to 10, or even just thinking about categories, 5 different categories, from poor to excellent. We can make sense of these ordinal variables in the terms of means and standard deviations, and because of that, we can then treat them somewhat quantitatively and do relationship tests. And again, we'll learn much more in detail about these tests in the weeks to come. But I want to talk about a little bit about the independent and paired samples t-tests. So when I mean by one group, I mean if we're looking at tests before and after, we're looking at a group of children and we have them go through a weight loss program. We measure their weight before the weight loss program, and then we measure their weight after the weight loss program. Because the sample in itself is just one group of people, the two time points that we're really looking at in terms of difference and seeing if there's a difference between the means is before and after. So this is an example of a dependent samples t-test or a paired samples t-test where the one group has two different means from time point A to time point B. Whereas independent samples t-tests, when we have two different groups, when we have men and women, or a group of people who are considered overweight and obese, and those who are considered normal and underweight. We have two separate groups, and we only have two groups that we're trying to see if there's a difference between. This is when we conduct an independent samples t-test. But if we have three or more groups, let's say we're looking at the example from Chapter 7 in-class exercise, looking at homicide rates between Americans, Europeans, and Russians. Well, in this case, we have three different groups that we're trying to see if there's a difference between on a quantitative variable, in this case homicide rates, number of homicides committed in a year. In this case, we're going to then conduct an ANOVA, a one-way ANOVA. So make sure you know this table here, because this is really going to help you in terms of how do we know what tests we're going to run, whether it's by hand or looking at SPSS output. And being able to know this table here will allow you to complete your final project, or it's going to be an independent study where you create your own research question, hypothesis, pick your own variables, run the analysis, and tell me what you found out. You need to know which test statistic and which statistical analysis you need to perform. So once you've ran your test statistic and you have it, you then make a decision. And this is when you decide whether or not you reject the null hypothesis, which is also known as accepting the alternative, or you fail to reject the null, or you're accepting the null hypothesis. And then you're really asking yourself, is your test statistic big enough, either in a positive or negative direction, to reject the null hypothesis? And so making your decision. So if we have hand calculations, this is where you compare your calculated test statistic to a critical value. And we're going to have tables that we're going to look at to give us our critical values. And we use degrees of freedom, which we'll hand calculate, and we're also going to use our alpha level, our significance level, that we set in order for us to find our critical value that we compare to our test statistic. if we have SPSS, our output is going to give us our p-value, and we compare that p-value to our alpha level. And so the standard cutoff p-value, when we set our alpha level, is 0.05. So again, in other words, if there is a 5% chance or less that the null hypothesis is true, then we'll reject the null hypothesis. So if we get a p-value of 0.04, or 0.03, or 0.0001, then we're going to go ahead and reject the null hypothesis and accept our alternative hypothesis. So this is just a visual. We'll see much more later on when we talk about making our decision for each of our own tests. Really thinking about our normal distribution curve, and thinking about a one-tailed test. We know that underneath the curve is 100% of all values. And so if we say that we're going to have our alpha level at 0.05, well, we're going to really say that our 5% is the risk we're willing to take. And really looking at this, we're going to see that 95% of all the values, right? This is going to be our null hypothesis. If the null hypothesis is true, 95% of all values are going to fall in here. But if we get our test statistic, and our test statistic falls within this rejection region, bigger than the critical value, where the 5% of all other values exist, then we're going to reject the null hypothesis. We're going to accept the alternative, which states that there is a difference, or that there is a relationship. So this concludes part 2 of chapter 9. Go ahead and move on to part 3 of chapter 9 to learn about confidence intervals and learning about some calculations for this chapter.